What's the problem? ശരി. So, two boilers are there. ഒന്ന് ചിത്രം വെച്ചാൽ ഇതാണ്. Two boilers are there. One with a superheater and other without superheater. Both are delivering equal quantities of steam into a common main. The pressure in the boiler and mains is 20 bar. Temperature of the steam from the boiler to superheater is 350 degrees Celsius and temperature of steam in main is 250 degrees Celsius. Determine the quality of steam supplied by the other boiler. So here, the figure is like this. There are two boilers. Okay. Two boilers. One is here, another one is here. Both are delivering the steam to me. Okay. There is a boiler, another boiler to me. Both are delivering steam to me. So one is the superheater, another one is without superheater. Okay. The pressure in the three one that is two for two boiler and one main is 20 bar, 20 bar, 20 bar, and 20 bar. The pressure in the boilers and the mains is 20 bar. Temperature from the steam from a boiler with a superheater is 350 Celsius. It is 350 degrees Celsius. It is the superheater. 350 degrees Celsius. This one. 350 degrees Celsius. And temperature of the steam in main is 250 degrees Celsius. So you want to find the X value of the other boiler. X value of the steam with the other boiler. That's the question. Okay. These data are given here. So here you want to find the value for X for boiler 2. X1, X2 എന്ന് പറയാം. X എന്ന് പറയും ഏതെങ്കിലും വാല്യൂ എടുക്കാം. So here we are doing the thing that we are equating the enthalpy values, that is H1 plus H2 equal to H main. The enthalpy from 1 and 2 both are equal to H main. അതാണ് നമ്മൾ എടുക്കുന്നത്. So you want to find an equation for H1, that is from superheater to main, H2 that is from second one to main, and third one is the equation for the H main. And you are solving that equation and you are finding the unknown term, that is X. Okay, ഇതാണ് നമ്മൾ ചെയ്യാൻ പോകുന്നത്. So from first one you find the value of H1, that is boiler 1 with the superheater. Okay, 1. You are finding the equation for H1 for 1. H1 അല്ല, total heat transfer. That is for to find the value of the H equation, boiler 1, boiler B1. Take this B1. T has a pressure of 20 bar and temperature of 350 degrees Celsius. 350 degrees Celsius. So you will get the value of H here. What is the H value here? It is the equation for superheater. It is the superheater. It is the boiler with the superheater. So you want to take the H superheat here. H superheat. We have 20 bar pressure and temperature 50 degrees Celsius. You can plot a value directly from the data book plus superheater table. superheated table എടുക്കുക. Then pressure with 20 bar. Pressure 20 bar and to 350 degrees Celsius. You can plot a value for H superheat. Here the table of superheat. We have pressure 20 bar. 20 bar here. This TS value is here we want to find the H superheat value. H superheat value we have 3071.8 300 degrees Celsius, and next one is 400 degrees Celsius. It is 3276.6, right? ഈ രണ്ട് വാല്യൂ ആണ്. അപ്പോൾ പ്രഷർ 20 ബാറിൽ വരുന്ന 350 ടെമ്പറേച്ചർ ഉള്ളത് കൊടുത്തിട്ടില്ല. Is given that for 300 degrees Celsius is given and 400 is given. So you want to interpolate. You want to take the middle value of the two. That is, first one is from data book, from steam table for superheated steam. For superheated steam, we have 300 H superheat equal to for 300 degrees Celsius 20 bar is given as 3071.8, right? ശരിയല്ലേ? For 400 Celsius it is given as 3276.6. So you want to get the value for 350. 350 ആയതുകൊണ്ട് പെട്ടെന്ന് കണ്ടുപിടിക്കാം. That is, add the 2 and divide by 2. You will get the value for 350 degrees Celsius. Is 3071.8 plus 3276.6 divided by 2. You will get the H superheat value. Or there is an equation for finding the value for H superheat. To find the value for H superheat, we have an equation that is H superheat equal to HF plus HGF, HF plus HFG plus Cp into T superheat by Ts. I equation which is converted. Or you can find H superheat equal to HF plus HFG plus Cps into T superheat minus Ts. So for this purpose, we want to know the value for HF, HFG and Ts. So take the table. Take the table of 20 bar pressure. 20 bar pressure. Find the value for HF, HFG and Ts. Easy we can bridge. The two method, anyone you can use. First one or second one. If it is given that temperature and pressure of superheated steam is given in your problem, you can take this method. Okay. If the temperature value and pressure value for superheated steam is given, you can take the first method. But if the temperature is given, but the pressure is not given, any one of the property is not given for superheated steam, you cannot take this method. പറ്റില്ല അല്ലേ? ഇതിൽ ഏതെങ്കിലും രണ്ട് തന്നാൽ മാത്രമേ, if pressure and temperature is given, you can take this method. ഇത് രണ്ട് തന്നിട്ടുണ്ട്, നമുക്ക് ഈ മെത്തേഡ് യൂസ് ചെയ്യാം. തന്നിട്ടില്ല എങ്കിൽ you can take this method. ഈ മെത്തേഡ് ചെയ്ത് പഠിക്കുന്നതാണ് ശരി. In your answer key, this equation and this problem is done. ഈ മെത്തേഡാണ് ചെയ്തിട്ടുള്ളത്. Is HFP, HFG plus Cps into T superheat minus Ts. To find this value, the Cp value is given in your problem. Okay. So the value for X superheat, if you are finding by two method, the value will be HFG equal to 3106.8 kilojoule per kilogram. And the method ചെയ്യുമ്പോൾ ചെറിയ വ്യത്യാസമൊക്കെ വരും. Okay. If there is any difference, neglect it. 3106.8 kilojoule per kilogram HFG value. Then second case, that is boiler B2. Boiler B2. Here you can take, it is not a superheated boiler. It is a normal saturation type boiler. Okay. So you can take the say normal equation to find the value of H equal to HF plus HFG. HF plus X into HFG. Okay. HF plus X into HFG. Trace fraction is given. If trace fraction is given, HF plus X into HFG. But here trace fraction is not given because you want to find the value. So you want to take this equation. HF value and HF value is known. HF superheat. HF value and HFG value can be found out by using data book. Okay, ആ വാല്യൂ എന്താ നമുക്ക് ആവശ്യമുണ്ട് എഴുതി വെക്കുക HF value, HFG value, TS value and VG value. From data book, pressure table, or 20 bar pressure, you want to take the whole readings HF value, HFG value, TS value, etc. And only unknown term is X only. So that is the one you want to find out. Okay. HF plus X into HFG. HF value is for 20 bar. HF value is 908. 908.6. And HFG value is 1888.6 kilojoule per kilogram. Kilojoule per kilogram. 20 bar. HF value by HFG value. If you got the value, just substitute it the equation and you will get an equation. You cannot solve it because the X value is not known. So just write down the value. It's 908.6 plus X into 1888.6. So that is the value for H2 for H boiler 2. First one is H superheat or H1. Second one is H2 boiler 2. You got an equation. Only unknown term is here is X. And find the H value for main. H main. H main എന്ന് പറഞ്ഞാൽ H main means is a superheater. There is a steam coming from a superheated boiler വരുന്നുണ്ട് അല്ലേ? Steam coming from a superheated boiler. So the steam occupies in mains will be your superheated state. ഇവിടെ സാച്ചുറേഷൻ വരുന്നുണ്ട്, സൂപ്പർ വരുന്നുണ്ട്. ഓക്കെ, ദെൻ രണ്ടും കൂടി വന്നു കഴിഞ്ഞാൽ ഇവിടെ സൂപ്പർ ഹീറ്റഡ് ഉണ്ടാവും, സാച്ചുറേറ്റഡ് ഉണ്ടാവും. സാച്ചുറേറ്റഡ് സ്റ്റീം വരുന്നുണ്ട്, സൂപ്പർ ഹീറ്റഡ് സ്റ്റീം വരുന്നുണ്ട്. രണ്ടും കൂടി കൂടിക്കഴിഞ്ഞാൽ ഏറ്റവും വലുതായിട്ടുള്ളത് സൂപ്പർ ഹീറ്റഡ് ആണ്. സോ ഈ മെയിൻസ് എന്തായിരിക്കും? സൂപ്പർ ഹീറ്റഡ് ആയിരിക്കും അല്ലേ? മീൻസ് എന്തായാലും സൂപ്പർ ഹീറ്റഡ് ആയിരിക്കാം, കാരണം സൂപ്പർ ഹീറ്റർ സ്റ്റീം വരുന്നുണ്ട്. സൂപ്പർ ഹീറ്റർ സ്റ്റീം ഇവിടുന്ന് വരുന്നുണ്ട്, സൂപ്പർ ഹീറ്റർ അല്ലാതെ ഇവിടുന്ന് വരുന്നുണ്ട്. അപ്പോൾ സൂപ്പർ ഹീറ്റർ വെച്ചിട്ടുള്ള സ്റ്റീമാണ് ഇവിടെ വരുന്നത് കൊണ്ട് തന്നെ ഇവിടെ സൂപ്പർ ഹീറ്റർ സ്റ്റീം ഉണ്ടാവും. സോ വി വാണ്ട് ടു കൺസിഡർ ദ മെയിൻസ് ആസ് എ സൂപ്പർ ഹീറ്റർ ബോയിലർ അല്ലേ? സൂപ്പർ ഹീറ്റഡ് സ്റ്റീമുള്ള ബോയിലറായിട്ട് കൺസിഡർ ചെയ്യണം. സോ അങ്ങനെ കൺസിഡർ ചെയ്യുമ്പോൾ യു വാണ്ട് ടു ടേക്ക് ദ ഇക്വേഷൻ ഫോർ എച്ച് മെയിൻ ആസ് എച്ച് എഫ് പ്ലസ് HFG plus CPS into T superheat minus T main. Sorry, T superheat minus TS. You want to take this equation to find the value for H main or H superheat. എന്തുകൊണ്ടാണ് H main or H superheat ആവുന്നത്? You know that there is a steam coming from the superheated steam boiler, and that superheated steam will arrive at the particular main. Therefore, the main occupies the steam coming from superheated boiler, that is a superheated steam. Therefore, H main can be also be considered as a superheated boiler or superheated main. So you want to, if you want to find the H value of main, you want to take this equation. Equation use ചെയ്യണം. Superheated കാണുന്നതിന്റെ same equation തന്നെ use ചെയ്യണം. So HF value is a known value, that is 20 bar itself. Pressure 20 bar ആയതുകൊണ്ട് you can take the same reading that we have wrote here. Only the same reading in നമുക്ക് യൂസ് ചെയ്യും. That is HF value as 908.6, HFC value as 1888.6. Okay, you can take the same reading because the pressure here it is 20 bar itself. 20 bar itself. If the pressure of the main is given as 18 bar or 25 bar itself something, you want to take again the reading of HF value, HFG value and TS value from the table related to that given pressure. ഇവിടെ 20 bar തന്നെയാണെന്ന് പറഞ്ഞുകൊണ്ടാണ് we have taken the same reading. If it is given as 15 bar or 1.8 bar or 10 bar itself, you want to take that reading. So here all the boilers have possess the same 20 bar pressure, so you want to take the reading only at once. That is, we have written that HF value, HFG value is also written. TS value നമുക്ക് ആവശ്യമുണ്ടെങ്കിൽ TS value എഴുതി വെക്കണം. Okay, TS value also and we find out 212.4 ആണ് TS value, 212.4 degree Celsius for 20 bar. So here we have the equation for H main, that is HF plus HFG plus CPS into T superheat means T main. So ഇവിടെ difference വരുന്നത്, you will think that the H superheated one or first boiler value രണ്ട് വാല്യൂ സെയിം ആയിരിക്കില്ലേ എന്ന് നിങ്ങൾക്ക് തോന്നാം. Because the same equation we are using, the same reading of CP value, HF value, HFC value are taking, TS value are taking. The same value is taken for the two, that is for mains and first boiler. രണ്ടും same value ആയിരിക്കില്ലേ എന്ന് നിങ്ങൾക്ക് തോന്നാം. It will not be same because here you want to take the H superheated value as figure നോക്കുക. Here for the first boiler we are taking 20 bar and 350 degrees Celsius. 20 bar and 350 degrees Celsius. So if we are doing this equation here for the boiler one, you are taking 350 minus 212.4. TS value is 212.4 from table value 212.4. We are taking this reading. If you are considering this condition, main ആണ് എടുക്കുന്നതെങ്കിൽ അവിടെ നമ്മൾ 350 minus അല്ല 250 minus ആണ്, because the temperature, that is to superheated temperature in the main is 250 degrees Celsius. But 250 minus 212.4 ആണ്. Okay. 250 minus 212.4. അത് മാത്രമല്ല വേറൊന്നും കൂടി ഉണ്ട്. That is, listen here. ഇവിടെ മാസിന്റെ കാര്യം പറഞ്ഞില്ല. The mass is not explained here. But we know that if mass is not given, we are taking mass as 1 kilogram. Mass as 1 kilogram. Therefore, we are using this equation as HF plus HFG plus Cp delta T. Cp T super given Ts. If mass is given as 5 kilogram or 10 kilogram, we are taking mCp delta T. That is m as 10 kilogram or something. If mass is not given or mass in a we are taking it as a 1 kilogram. So we are neglecting it. So we are taking this equation as Cp delta T only. That is the method. So take this condition. Here we are taking boiler. In this condition, boiler 1 kilogram mass. We are considering it as 1 kilogram. We are boiler 1 kilogram mass of steam. So this both steam is entering into mains. Mains mass 1 kilogram I consider. My question is, if mass is not given, we are taking it as a unity. That is 1 kilogram. So here mass is not referring in the problem. So we are considering it as a 1 kilogram. For one boiler, we are taking within equation number, we are considering mass is equal to 1 kilogram. And when we are considering this equation, we are also considering it as 1 kilogram. And this 1 kilogram steam is entering into this particular mains. So what is the mass of this steam in the main? What is the mass of the steam in main? 1 plus 1, 2 kilogram, right? Is that clear?
Sir.
Okay. Therefore, this equation we 2 into 2 into. That is mass is equal to 1. Here cancel it is a mass is equal to 2. Therefore, HF plus HFG plus CPS into 250 minus 212.4. The whole value into 2 G. You will get the reading of H main. HF value is 908.6. HSG value is 908.6 plus HFG value is superheated condition. The both first one and third one we are considering it as superheated state. So we are not considering the dryness fraction value here. Only dryness fraction value is considering in the second boiler. It is not in superheated state. It is in saturated state. 908 plus HFG value is 1888.6 plus CP value is given as 2.25 into 250 minus 212.4. The whole value into 2. We'll get the value of H main as 5763.6 kilojoule. 5763.6 kilojoule. So you get the value for H1, H2, that is second boiler, and H main or H3. First one value is 3106.8 kilojoule per kilogram. Second one, we don't get a value because there is a dryness fraction is there, because it is saturated steam. Dryness fraction. Therefore, 908.6 plus x into 1888.6 is value. Then third value, that is H main, is 5763.6 kilojoule. 5763.66 kilo. So write down the equation. That equation we have written the first, that is whole equation H1 plus H2 equal to H main. That is H over superheat, that is 1 plus H2 equal to H main. Both are same. It is first one is H superheat is 3106.2. Not 8, not 2, it is 8. 3106.8 plus second one, that is 908.6 plus x into 1888.6, that both equal to H main, that is 5763.6. 5763.6. So solve it. Only the unknown value it is x. Only unknown value is x. Therefore, solving it into area, that is 4015.4 plus 1888.6x equal to 5763.6. Therefore, x equal to, solve it, 5763.6 minus 4015.4 all divided by 1888.6. You will get the Rayleigh fraction value, that is quality of steam. What is the value?
.925.
Yes, 0.925. There is no unit for Rayleigh fraction. This is a quantity. So quality of steam supplied by the second boiler or the other boiler is 0.925. This is the value. This is the question. Okay. So I'll explain the question once more. Initially, we have solved the previous questions. Like the Rayleigh fraction value is the given in the problem. You only want to substitute the Rayleigh fraction value to find the value for internal energy, enthalpy, or etc. 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 So in this question, you want to find the value for Rayleigh fraction x. So how to find the value of Rayleigh fraction? The question is it is a special type question, that is two boilers are there. One is a superheated state, one is of saturated state or normal state. The two steam are delivering the steam into a single or common main. Temperature of the first one and main is given. Pressure of the three is given, that is same. If it is different, you want to take the different values from the different table. Okay, it is 20 bar given. So here we know that x വരുന്ന equation ഉണ്ടാക്കണം, integrate ചെയ്യണം, എന്നാലേ നമുക്ക് കിട്ടുള്ളൂ, അറിയാം. If x വരുന്ന equation കിട്ടാൻ വേണ്ടി you can take the value for equation for enthalpy, the three condition. First one is given as superheated steam. So you want to take the H superheated value, H superheat. Second one, we have taken saturation stream. There is a saturated വരുമ്പോൾ അതിൽ Reynolds fraction വരും. You want to take the equation considering Reynolds fraction. And third one is at the superheated തന്നെയാണ്. Because superheated stream is arriving there. You want to take the reading for superheat. There is an equation for superheat. Don't want to forget it. Then you find the value. We already find the value for H main, H superheat, and there is an equation for H2, that is H of boiler saturation, including the Reynolds fraction value. Just equating the H1 plus H2 equal to H main, you can arrive the solution that X. If any doubt, you can ask personally.